Welcome back. Today we're going to be talking about distributive property and factoring. Our content objective is students will be able to factor expressions using the greatest common factor, for short GCF, and checking by using the distributive property. Our language objective is students will be able to state distributive problems correctly, so we should be able to read them correctly. And why am I learning this? Well, it's important for factoring polynomials in a later math class. So far, we have been using the distributive property to simplify an expression. So in this case, we've distributed a 5 and gotten 5x plus 15. In this case, we distributed 6 and got 6y plus 42. And in this case, we distributed 3 and got 3m minus 24. Notice real quick, all of these expressions, so these two expressions are equivalent. They represent the same exact value. These two values are equivalent, and these two values are equivalent. Now, today's focus is we're kind of, in a sense, working backwards. Now that we're given an expression like this, we want to make it look like this. So we're going to be doing something called factoring. Factoring a common factor to make it look like something like that. So, before we do that, what we really need to get good at is finding the greatest common factor. The greatest common factor is basically the largest number you can think of that divides evenly into other numbers. So for example, if we wanted to find the greatest common factor, aka GCF, for the 15 and 12, what I'm going to think about is what number can I divide both of them, but it's the largest number that I can think of. My answer would be 3, okay, because 3 times 5 is 15, 3 times 4 is 12, and that's the biggest factor that I can come up with. What about number 2, a 30 and a 42? Again, you want to find the greatest number that divides evenly into both, and that would be a 6. Number 3, we have a 14 and 21. Immediately what jumps to me, because I know right away the two factors I can think of for 21 is 7 and 3. And guess what? 7 goes into 14 evenly, so I'm going to go ahead and say 7 is my greatest common factor. 24 and 36 have a lot of factors, but I'm going to think, and I'm going to say, Some people might say 6, but you have to be careful. There's actually a greater factor, and that would actually be a 12. And then for number 5, 50 and 15, what goes into both of those evenly? I'm going to say the answer is 5. 5 times 10 gives me 50, and 5 times 3 gives me 15. So, remember, a greatest common factor is basically the largest number you can think of that divides other numbers evenly. No remainders. Okay, so here we're going to practice finding the missing factor. Basically, factors are the numbers that are being multiplied to give you the product. So here, 8 times what gives me 32? The answer is 4. So I'm going to say I concluded that the missing factor is 4. So notice 4 and 8 are factors of 32. Again, these numbers that are being multiplied to give you the product are called factors. Okay, they're called factors. Okay, what's the missing factor? 4 times what gives me 48? It's going to be a 12. So 4 and 12 are factors of 48. They make up the 48. Okay, number 8. 2 and what gives me 16? I would say the factors is 2 and 8. Number 9, let's see, 3 and what gives me 120? My answer would be 40. So the factors are 3 and 40 to make the product of 120. Number 10, what are the factors to make 54? I'm going to say 9 and, hopefully you guessed right, it's going to be 6. So 9 and 6 are, again, the key word is they are factors. So again, using the sentence frame, I would be saying I concluded that the missing factor is a 6. So please understand both of these are factors of 54. Okay, number 11. First of all, 12 and what gives me a product of 132? I'm going to have to go with 11. So I'm going to say I concluded that the missing factor is 11. So the key thing to remember about this is factors are basically the numbers that are being multiplied to give you the product. Time to factor by using the greatest common factor. So how do we do that? Well, first we need to figure out what 8 and 12 both have in common. I'm going to say they have a 4 in common. So because they have a 4 in common, kind of like the way you would reduce a fraction, you would divide. Same thing here. We are factoring out a 4, so I'm essentially dividing each term by a 4. So 8x divided by 4 is 2x. Here, a positive 12 divided by a 4 is going to be a positive 3. And there you have it. Now, basically what this means is I would consider 4 and 2x plus 3 as the factors. Okay, like so. Clear that real quick. They are considered to be factors of 8x plus 12. So keep that in mind. Now let's try number 13. So you're going to try to figure out what is the greatest common factor between a 7 and a negative 21, which I'm just going to count as, let's just think about positive factors first of all. I'm going to say I can factor out a 7 because I can divide both of them by 7 evenly. So we're going to factor out a 7, and since we're doing that, we're basically dividing each term by 7. 7c divided by 7, the 7's cancel out, leaving with just 1c, which I'm just going to write as a c. A negative 21 divided by 7, that is going to be a negative 3. So it's just going to be, the factors are 7 and c minus 3. Those are the two factors, 7 and c minus 3. Because I know this because if I multiply these two together, I should end up with the same thing. Now, please understand, let me just quickly rewrite what we had here. This, again, is equivalent to the original one here, and factoring out the 7, leaving me with this, is also an equivalent expression to the original expression there. So again, equivalent expressions basically represent the same thing, they just look different from each other. Okay, so now with that said, I'd like you to pause the video and try numbers 14 through 17 by yourself. Okay, so let's see how well we did. So for number 14, I'm going to say between 12 and 14, the greatest common factor is going to be a 2. So for those reasons, I'm going to go ahead and factor out a 2. So 2 and put a set of parentheses. We're going to divide this by 2. 12w divided by 2 is 6w. Divide a positive 14 by 2. That's going to be a positive 7. And that will be our answer. Number 15 here, the greatest common factor between 6 and 21, I'm going to go with 3. So we're going to divide each term by a 3. So here, 6y divided by 3 is going to be 2y. Negative 21 divided by 3 is going to be a negative 7, so that would be our answer. Now, something that you want to be very careful about is check, did you actually find the greatest common factor? How would I know? Well, I would know if I can look at the last two numbers within the parentheses, the coefficient and the constant, and check. Is there anything else I can reduce them by in a sense? If the answer is no, then I'm pretty sure I have the greatest common factor. If I don't, that means I can continue to pull out a factor that they both have in common. Okay, so number 16, let's see, what could I factor out between 27 and 15? I'm going to go with 3. Okay, so we're going to divide this by 3. So 27h divided by 3, that's going to be 9h. And then here, a negative 15 divided by 3, that's going to be a negative 5. So here, notice 9 and 5 have no other common factor, so I'm pretty sure I'm right. Now, number 17, what's the greatest common factor between 32 and 32? Hopefully your answer is 32. So in order to solve, I'm going to have to divide both terms by 32. This is going to leave me with 1d, which is just d. I'm going to do negative 32 divided by 32, which is going to be a negative 1. So I'm going to put minus 1. So here, notice the only factors left is just basically a 1 and negative 1. I could just leave it like that because they don't have any other common factors other than 1, which is not going to do me any good. Now what we're going to do is factor using the greatest common factor with fractions. So one very important thing that we need to make sure we do before we factor fractions is make sure we have common denominators. Guess what? The denominator is a 10 and a 10, so we're ready to start factoring. So the very first thing you're going to want to do is start with a set of parentheses. And then outside, we're going to go ahead and figure out what we can factor out. So here we have 3 and 9 in the numerator. That means I can factor out a 3 from the numerator. And then as for the denominator, you're going to find that we can factor out a 10 and a 10. So that just means we can factor out a 10. So now to figure this out, if I factor out 3/10 from 3/10, I am left with 1r, which is just r. So you could think of it as we're dividing by 3/10, kind of similar to what we were doing earlier. 3/10 divided by 3/10 is 1. Sorry, correction is 1. Now I'm going to repeat this process here for 9/10. If I factor out 3/10, I would be leaving a positive 3/1, which is just 3. Now, how did I do that? Well, you can think of it as you factored out a 3 from the 9, which is leaving me with 3, and you factored out a 10 from the 10, which gave us a 1, which will reduce to 3/10 times a quantity r plus 3. Now, I'm going to go ahead and repeat the process for number 19. First, I need to check that my denominators are the same. Well, let's see, this one needs to be turned into a fraction to compare. These denominators are not the same, and I could make them to be the same simply by multiplying this denominator by 2. So now that's going to leave me with 1/2 a minus 4/2. Now you'll notice here, 4/2 is still 2, so these are definitely equivalent. Now that we have that, what we're going to do is look in the numerators to see if there's anything we can go ahead and factor out. Between a 1 and a 4, the only factors in common would simply be a 1. Now between a 2 and a 2, definitely they have a 2 in common that we can factor out. So here, if I factor out a 1/2 from 1/2 a, I'm just basically left with a. Again, you can think of it as, hey, I'm dividing it by a 1/2. That's going to leave me with a. Now, here is a negative 4/2. If I factor out a 1/2, you can think of it as I'm factoring out a 1 from the 4, so that's going to stay a 4. And I'm factoring a 2 from a 2, so that's going to leave me with 1, which we would just rewrite as 1/2 times the quantity a minus 4. Moving on. So here at this point, what I'd like you to do is go ahead and pause the video and try numbers 20 and 21 by yourself. So for number 20, what we're going to do first is make sure we have common denominators, which gratefully we do. So we're going to go ahead and start with our parentheses. Between the numerators, what factors do they have in common? I would say they have a 4 in common. And as for the denominators, well, I can see here they both have a 5 in common. So let's factor out a 5 from the denominator. So here, if you factor out 4/5 from 4/5 z, guess what? All you're left with is z. You can even check by just simply dividing by 4/5, because essentially that's what you're doing. And here we're going to go ahead and put subtract. You can also, just let me show you, divide by 4/5 just the same. So that's 28/5 divided by 4/5, which is equivalent to 28/5 times the reciprocal, which is 5/4. These 5s will cross cancel. 4 and 28 have a 4 in common. That's going to leave me with 7/1, which is just 7. Now, you could have also gone the route of saying, okay, if you factor out a 4 from 28, that leaves me with a 7. If you factor out a 5 from 5, you're left with 1. 7/1 is just 7. So that is our answer here. Now, a good thing to do, like on a quiz or test, is you might want to distribute it and check to see if you are left with the original expression. If you are, you're pretty safe that you have the correct answer. Now, one thing you have to also be mindful about is make sure the numbers within the parentheses are, they have no other common factors. Okay, so let's check number 21. I need to check that the denominators are the same, so I'm going to go ahead and put this over 1. They're not the same, so I'm going to have to change this by multiplying it by 5, which leaves me with 1/5 b minus 5 over 5. So here what I'm going to do now is start with some parentheses and take a look simply at the numerators and the denominators. Between 1 and 5, the only thing those two numbers have in common is a 1. And for 5 and 5, I'm going to say a factor that both those numbers have in common is a 5. So here, hopefully you understand if you are factoring out a 1/5 from 1/5 b, you're just left with b. And here, if you factor out a 5, first of all, let's put minus so we don't forget about that. If you factor out a 1 from 5, you're left with 5. And if you factor out a 5 from 5, you're just left with 1. So that's going to leave me with 1/5 times the quantity b minus 5. So that is our answer. Now, the other route would simply be if you wanted to divide both sides by 1/5, that would still give us the same answer. It does take a little bit longer, but that also works. So we've done fractions and we've done whole numbers. The only thing left is to factor using the greatest common factor with decimals. So what I like to do is ignore the decimal for a second and just look at the numbers on their own. So I'm going to think of it kind of like as a 9x plus 36. Between 9 and 36, I would say both of them have a 9 in common. So I'm going to go ahead and start with my parentheses and start with a 9. But guess what? The decimal, notice they're both into the tenths place, so I'm actually going to factor out a tenths, 9/10, since both of them are 9/10 and 3 6/10. So here, if I divide this by 9/10, you'll notice 9/10 divided by 9/10 is factored out to leave me with only 1x. Put a 0 there to make it better. And then we're going to go ahead and factor out a 9/10 here as well. So I'm going to do some side work. Let me just give myself some space here. We're going to do 3 6/10 divided by 9/10. We're going to move our decimal one place over. 9 is going to go into 36 4 times, so that's just a plus 4. And real quick, before I stop, I'm going to check my coefficients, a 1 and a 4 here. Are there any common factors that 1 and 4 have? Nope, that's it. So that is our answer. Now let's try number 23. So here I'm just going to think of it as a 16 and a 24. Between 16 and 24, I'm definitely thinking I can factor out an 8. So starting with parentheses, before I stop, I'm going to take a look and ask myself, this is to the tens place, this is to the tens place as well. So let's go ahead and try and factor out an 8/10. So let's try that. So here, if we have 1 6/10 and we factor out an 8/10 to both of these terms, you're basically dividing. So we're going to do 1 6/10 divided by 8/10, move the decimal over 1. 18 goes into 16 2 times, so that's going to leave me with a 2x. Now here, this is going to be minus. We have 2 4/10 divided by 8/10. Move the decimal over one place. We're going to say 8 goes into 24 3 times. So real quick, do 2 and 3 have any other common factors you can factor out? The answer is no, so your answer is simply going to be 8/10 times the quantity, 2x minus 3. Okay, now it is your turn. What I'd like you to do is go ahead and try number 24 and 25 all by yourself. Okay, so let's check for number 24. I want you to think of it strictly as a number, so just 23x plus 46. Between the two, I'm definitely going to say I think I can factor out a 23. So before I do that, notice both of these are in the tenths place, so I might want to factor out a 2 3/10. So with that, what is 2 3/10 divided by 2 3/10? This is just 1, so I'm left with a 1x, which I'm going to write as x. I'm going to also factor this by 2 3/10. Here I'm going to have to definitely use some side work, so we're going to do 4 6/10 divided by 2 3/10. The decimal needs to be moved once over to make it a whole number. I'm going to say 23 goes into 46 2 times evenly. So that's going to be a plus 2. Now, this coefficient is a 1. 1 and 2, do they have anything in common that you can still factor out? The answer is no. So your answer is just 2 3/10 times the quantity x plus 2. Now moving on to the last one. So here we have a 3 2/10 x minus 1 28/10. So real quickly, let me check if a 3 2/10 can go evenly into 1 2800. So in other words, just think of it as 32 and 128. Can 32 go into 128 evenly? Let's just check real quick. 32, let's estimate maybe 4. 2 times 4 is 8. 4 times 3 is 12. So it does go in evenly. Since both fractions have a 32 in common, we're going to go ahead and factor it out. Now the only tricky thing is deciding, am I going to factor out a 32 hundredths or 3 2/10? Since between here we have a tenths and a hundredths, we do pick the place value further to your left. So in this case, we are going to go to the hundredths. So let's factor out a hundredths. So when I do that, if I'm dividing by a 32 hundredths, if you divide this, you are going to end up with 10x minus 4. Okay, so let me show you real quick. We're basically doing 3 2/10 divided by 32 hundredths. Move the decimal over 2 places. I would say 32 goes into 32 once. That was nice. Bring down the 0. 32 goes into, oops, this is a 0, not a 1. Goes into 0 0 times, and that's how I got my 10. And here we're 1 28 hundredths divided by 32 hundredths. Move your decimal places 2 places over, and you're going to see that it goes in 4 times evenly. Now there is an issue with this answer. Notice 10 and 4 both have a 2 in common that I can factor out still. So I'm going to have to do that. So let's factor out a 2. That means the 2 is now on the outside, so it's going to be multiplied. So here we're now left with 64 hundredths times the quantity, 5x minus 2 as our answer. Guess what? That concludes the lesson for today. Thank you so much for tuning in, and as always, until next time, bye!